Hello everyone. Today, my classmate Ben and I, Michael, will be talking to you about artificial intelligence and its energy related to it. Now, Ben will start with the basics of our topic today.
Okay, let's first talk a little bit about AI, which is short for artificial intelligence. Generally speaking, AI is the intelligence demonstrated by machines or the ability of computers and robots to do tasks that are usually done by humans. As a research field, artificial intelligence is really a very broad term that encompasses many subfields like machine learning, natural language processing, vision, and robotics. But I'm sure that whether you are a computer scientist or not, you must have heard about AI and had certain exposures to it, as artificial intelligence has gained lots of attention and popularity in our society and has been applied to pretty much every aspect of our lives in one way or another, including healthcare, education, automobile, finance, etc., because it is just that powerful. However, this power does not come without a cost. As the use of artificial intelligence has dramatically increased, the energy consumption of AI has also been quickly going up. People have begun to worry that this might become a serious problem. One major aspect of AI that consumes a lot of energy is its training. As the tasks people want AI to accomplish become more and more complicated, many have adopted deep learning, a subtype of artificial intelligence that relies on artificial neural networks, which are mathematical computations that mimic neurons in the human brain. Now, here's just a simple example of a neural network with 5 layers. In real applications, there can be many more layers and neurons per layer. In order to obtain the right model, the computer needs to figure out the best parameter values, and there can be hundreds of millions of them. To do that kind of computation, tremendous amounts of energy will be consumed. For example, to train Megatron LM, a model for natural language processing, NVIDIA ran 512 V100 GPUs over 9 days. A single V100 GPU's energy consumption falls somewhere between 250 and 300 watts. Assuming that it takes 250 watts, 512 of them will consume 128 kilowatts. And running them for 9 days, that's 27,648 kilowatt hours of energy. The average household in the US uses about 10,649 kilowatt hours of energy annually, which means the energy consumed by training just this one model can support roughly 3 average American families for an entire year in terms of energy. Another aspect of AI that consumes a lot of energy is data storage. As Sherlock Holmes, a great example of human intelligence, has famously said, "Data, data, data, I can't make bricks without clay." And the same goes for artificial intelligence. Data is the key to the success of artificial intelligence. The insane training process that we've just seen is heavily dependent on a wealth of data. For example, IBM's The Weather Company processes around 400 terabytes of data per day. People generated 64.2 zettabytes of data in 2020, which is about 58 billion terabytes of data, which could all potentially be useful to a piece of artificial intelligence. Thus, we need to store these data, and those facilities that store data require lots of energy. The largest data centers require more than 100 megawatts of power, which is enough to power some 80,000 US households. The data centers around account for about 2% of total US electricity usage, and worldwide, data centers consume about 200 terawatt hours per year, which is more than some countries. Some predicts that by 2030, computing and communications technology will consume 8% to 20% of the world's electricity, with data centers accounting for one-third of that.
As we have been talking about the energy consumption of data storage, one thing that I will be adding is that by 2035, the amount of data produced by humans will be about 2,000 zettabytes. People might think that the greater data that we have, the better it will be for humans as more advanced and complex models could be created. But the problem is that often we forget to think about the greenhouse gases emitted from these data. The main gas emitted is carbon dioxide, CO2, and as we all know and have learned is that CO2 leads to global warming as it re-radiates and emits and re-emits heat energy that is trying to leave the atmosphere into space. This causes the temperature of the Earth to increase. Moreover, an enormous amount of energy is needed for all of building the data centers as well as collecting and storing the data rather than only the electrical energy used in training the artificial intelligence models. And here, as you can see on the right, is an image which shows how global warming is affecting our Earth and how, as we can see, as how we think we are building a better future, we are actually draining our planet. As the CO2 emission levels are high, the industry is trying to limit it by two different ways. The first one is to make the data centers and their models more electrically efficient. While this sounds as something promising, but in fact, electricity only accounts for 10% of the CO2 emissions from all processes regarding building data centers to training an artificial intelligence model. The second way is using water as a form of evaporative cooling, which limits the usage of products released in CO2 as well as reduce energy losses. This requires a huge amount of water and this also leads to the pollution of the water, meaning it's wasted after it is used. Moreover, the artificial intelligence data centers use about 3% of the global electric supply, and while this seems like a small amount, it is actually about the same as the entire airline industry. This is also leading to 2% of the total greenhouse gases released into the atmosphere. Lastly, in order to reduce the risk of global warming and achieve a cleaner environment, the best method would be to switch to using clean energy resources with high energy efficiency. For our last topic of discussion today, it is regarding how businesses can make change towards environmental impact of businesses. The first way is to focus more on having high quality rather than high quantity. This comes from that most businesses tend to not use 90% of the data in their storage after 90 days from when they are restored. Instead, they could keep the data relevant for them in their storage and erase all unused and unnecessary data. And by doing so, they decrease their storage and thus less CO2 emission will be generated. Furthermore, businesses could adjust the types of artificial intelligence used and how it is used. These types would include spam filters, voice-to-text features, process automation, and others that have been earlier mentioned by Ben. Lastly, different processes require different systems, and these systems can vary from being an advanced dedicated system that have been trained over a large amount of data as to increase its accuracy, such as in smart personal assistants such as what we daily use in Siri and Cortana, or or they could have less dedicated systems trained on a smaller amount of data, such as in automating a billing process. Throughout this presentation, we hope that you got to learn about what artificial intelligence in businesses is and how they work at different levels, as well as their environmental impact and how that could be improved in the future. Thank you. Here, you can see our first set of references. Here, you can find our second set of references.